Compound interest practice problems. Sean deposits $6,500 at an 8% annual interest rate compounded monthly. How much money will be in the account after 7 years? So let's start by writing our equation again. A is going to be equal to P multiplied by 1 plus our rate divided by n, and then raised to the n times t power. So now let's fill this in. A is going to be equal to our principal, which is 6,500, and then we need to multiply by 1 plus our rate, which is 8%. But remember, we need this as a decimal, so this is going to be 8% divided by 100 is 0.08. We move the decimal point over twice. And then we divide by n. So what is n going to be? Well, in my last video, we saw that n was the number of times it is compounded per year. And it says here it is compounded monthly. Well, there's 12 months in a year, so n is going to be 12. And then our time, remember time has to be in years, and here we have our time, 7 years. So here is our equation set up. So let's see if we can simplify this a little bit before we put it into our calculator. 12 times 7 is going to be 84, and I don't think we can do any more simplification here, so let's go to the calculator and plug this in. 6,500 multiplied by 1 plus 0.08 divided by 12. And then we raise that to the 84th power. So our answer is going to be $11,358.24. So after 7 years, there will be $11,358.24. A deposit of $7,100 at a 2% annual interest rate compounded continuously. How much money in the account after 11 years? So this is continuous compound interest. So let's start with our formula for that. A, which is our total amount, is going to be equal to P, our principal, multiplied by E, and then raised to the R times T. So let's fill this in. A is going to be equal to our principal, 7,100, multiplied by E, and then raised to R times T. So what is our interest rate? It's going to be 2%. So we need to put that as a decimal, so 0.02, and then multiply by T. And remember, time has to be in years. And here we have 11 years. So now again, we're just going to have to throw this into our calculator, so let's go do that. So we have 7,100, and then we multiply that by E, and then raise E to 0.02 times 11. So our answer is going to be $8,847.14. So after 11 years, there will be $8,847.14 in the account. Human 1 deposits $10,000, earning 6% in simple annual interest. Human 2 deposits the same amount at 6% annual interest compounded annually. How much more money will Human 2 have than Human 1 after 15 years? So let's start with how much money Human 1 will have. human 1. So for simple interest, we know the total amount, which is what we're looking for, is going to be P times 1 plus R times T. So our principal is going to be $10,000, and then 1 plus our interest rate is going to be 6%, and as a decimal, that's going to be 0.06. And then our time is going to be 15 years. So now let's throw this into our calculator again and see what this is going to be equal to. So 10,000 multiplied by 1 plus 0.06 times 15. That is going to be $19,000. So after 15 years, human 1 will have $19,000. So now let's look at how much money human 2 will have. Let's first write out our compound interest formula. 1 plus R divided by n raised to the n times t. And now let's fill this in. For human 2, our principal is going to be the same, $10,000. Our rate is also going to be the same, says 6%. But what is our n? Well, it says it is compounded annually. So if n is the amount of times it's compounded each year, then n is just going to be 1. And any number divided by 1 or multiplied by 1 is just going to be the same, so we can just ignore the n's. We don't even need to write them. So if we raise this to our time, it's going to be 15 years. So now let's throw this into a calculator to see how much money human 2 has. So $10,000 multiplied by 1 plus 0.06, and then we raise that to the 15th power. So human 2 is going to have $23,965.58. So let's put that down over here. We have $23,965.58. So we need to know how much more money human 2 will have than human 1. So we need to take, so our answer is going to be human 2's money, and then we subtract human 1's money, which is 19,000. So we don't even need our calculator for this. We can just solve it like this. So the way I would solve this in my head is 20,000 plus 3,965.58. I would split up human 2's money like this, and then I would subtract 20,000 minus 19,000, which is going to be 1,000, and then I would add our other value here. So I split this up to where I had nice round numbers that I could easily subtract, and then I added back our complicated number, and so 3,965 plus 1,000 is very simple. It's just going to be 4,965 and 58 cents. So human 2 will have $4,965.58 more than human 1 after 15 years. And that's it for our example problems. Hopefully you found those helpful.